Hi, and welcome to my channel, JaberTime. Today I'm going to go over powers and radicals and extracting radicals. This is part 2, as you could see from right here. I do have more details and basic examples in part 1. Let's get started. We have extracting variables from radicals. From part 1 video, if you have the nth root of x to the power n, and n is even, use the absolute value of x. If n is odd, we discussed that and we showed you the graph, it stays x. We're going to use this in many examples in this video. So the main ones that we're going to be using are the second root and the third root. For the second root, if you have the second root of x to the second, in short we write it as square root x to the second, and that will be absolute value because n is even, n is 2. If n is 3, we have the cubic root of x to the third, as it shows right here, 3 inside and 3 outside. That's x by itself. Let's see some examples. The second root of x to the 4. Now these two numbers are not identical like n and n in the previous slide. So how we could do it? We could split them into two parts, and this is how we do it. That's one option. Because when you look at for the square root, you're looking for a number that you multiply by itself. So this, in this case, is going to be x to the second times x to the second. And if I continue from this side, I could think basically square root of x to the second times x to the second will be x to the second. Square root of 5 times 5, that is 25, will be just 5. Kind of like two items repeated inside will be one item because we're dealing with square root. In cubic root, we need 3 terms or 3 factors, not items, inside that repeats to be 1 outside. Or we could split them. If you split them, this one, that's a second root, and that's a x to the second, using the rule that we were looking at in slide number 1, we could use absolute value directly. Same thing for the second one. Well, if you multiply this by this, you get absolute value of x to the second, or differently, x to the second, because we don't need the absolute value. If we are squaring this amount, there is no need for the absolute value, because anything being squared is non-negative. So either way, you get x to the second. So in short, I use the right side here for this video as notes and reference formulas, so you want to keep this in mind. Examples will be on the left, anything extra as notes or formulas will be on the right. So basically we're saying the square root of x to the 4 equal x to the second. Out of this example, you want to keep this in mind. It becomes helpful and handy for other examples. Now if somebody wanna say like, oh, can I use the absolute value? Yes, you can, but it's not needed because x to the second is never negative. Absolute value will force any negative amount to be positive. But this amount is neither, it's not negative. It's non-negative number. X to the second is never negative, so no need for the absolute value, but it's not wrong if you keep it. So the square root of x to the 4, one way to look at it is square root of x to the second, that term being squared. Now we're looking at 2 here and 2 here, which we could apply the formula from slide 1, and that's the absolute value of x to the second, which is just x to the second. So, and that's what we need to take with us from this example. Here's another example. In this case, I have the 4th root of x to the 8, y to the 4. We could split them because that's one of the rules right here. So I'm going to apply this rule. Now to handle this, because this is n, which is 4, I could think about this as something to the 4, which is x to the second being raised to the 4. This is already n and n, where n is even. Now I have the n equals 4, which is even. I could apply the formula by applying the absolute value of x to the second and the absolute value of y. But the absolute value of x to the second is not needed as an absolute value. So that's my final answer. X to the second absolute value of y. One more time, these are notes, formulas to use as you're working and verifying your steps. I'm using this rule. When n is even, I use the absolute value. As you can see, n is even 4, n is even 4. Here's another example. One way to do this problem is think about x cubed, because we're under square root, as 3 pieces. 2 of them will be handled by the square root, and x by itself will be by itself. Cannot be extracted. Next, split them because of this rule. The first one is obvious for us now, which is absolute value of x. Square root of x, square root of y to the 4, which we saw earlier as y to the second. We're done. Next example, x to the 4, y to the 6 under the square root. We could split them because of this rule. We could split this into 2 parts. We could split this into 3 parts this way. Because y to the 6 could be written as y to the second times y to the second times y to the second. Then we could apply this rule and split them into parts. From there, I think it's obvious that this is absolute value of x, absolute value of x, absolute value of y, and so on, which simplifies to absolute value of x being squared and absolute value of y being cubed. We don't need the absolute value one more time here, so we could take it off from this right here. Next, here I have 16x to the 8 under a cubic root. We're going to use this rule. We're going to think about 16 as 8 times 2. Why? Because 8 is 2 times 2 times 2. We want to keep the 8 under the cubic root, because the cubic root of 8 is 2. We could see that back 2 times 2 times 2 will give me back 8. So the cubic root of 8 is of this format, or 2 to the 3rd to the 1/3, which simplifies to 2. And we're going to also think about x to the power 8, extract out of it or factor it, not just x times x times x 8 times. We're going to group them into x to the 3rd, because the cubic root of x to the 3rd is x. Keep those two in mind. Here we go. So instead of writing 16 as 2 times 2 times 2 all the way, I wrote it as 8 times 2, because I know that 8 could be handled with the cubic root. Same thing for x to the 8, x to the 3rd times x to the 3rd times x to the 2nd. We add exponents. 3 and 3 is 6 and 2 is 8. Now we split them with this rule. First one will give me 2. This one cannot be extracted, we'll keep it. This one cannot be extracted, we'll keep it. This will be as it shows right here, and this will be. We'll group this and this together. We'll put them in one piece. That's reordering. X to the 2nd, put it up front, put the cubic roots next to each other, put them as one piece, like this formula from right to left, backwards. And we're done with this problem. Let's move on to the second problem. We have 16 x to the 6. If you think about 16x to the 6, we could split them into 16. 16 is going to be handled. Square root of 16 is 4. Square root of x to the 6 could be split into x to the 4 and x to the second. That is something we covered. And that is also something we covered, which is right there. So we have that. And we're done. Just by writing it in short without the dots in between. One more. Negative square root of 8x cubed. Well, the 8 could be written as 4 times 2. And the x cubed could be written as x to the second times 1x extra. Now we could split this using this formula and go from there. We know this and we know this. That's a 2 and that's an absolute value of x. That cannot be extracted, we'll keep it. That cannot be extracted, we'll keep it. Rearrange, put the square roots together as one piece, and that's how it goes. 2 and x will be under the square root, and we have a minus 2 absolute value of x times the square root of 2x. Next, square root of 25 a to the second, b to the 8th, c to the 10. Let's use this rule again and split them. This is the second degree, square root of a to the second, which is absolute value of a, that's a 5. That could be written as the concept of 2 here and 2 inside, but b to the 4th to the second, c to the 5th to the second, so I could use the absolute value. Absolute value of b to the 4 is not needed, and these two will be grouped together. As you can see, it's not needed. We'll group these two together and we are done. Next, 81x to the 5th, y to the 12th under the 4th root. Let's split them first. Notice that 84 is 3 times 3, which is 9, times 327 times 3 to 81. So that is something we could handle. That will give me absolute value of x. That will give me absolute value of y to the 3rd. And that cannot be extracted. Put this together and we're done. I have still more examples, so let's keep going. Cubic root of x plus 3 to the 9th. Well, this is it's a cubic root. It looks like I forgot to put the 3 here. That's my mistake. I'm using the cubic root. I could see from here. Yep, it's a cubic root. Typo. My mistake. This should be a 3. I cannot do it right now at this moment in the recording. But this is the problem looked at from a different angle. Because I'm dealing with cubic root, we wrote the 9 as 3 to the power 3. So we have 2 powers, as you can see. Okay, in this case, n is 3. So we don't need the absolute value. And we're done. Now we have the square root. Here's the square root as notes, and that's a square root. That's a quick one, because that's a 2. We could apply this rule, and we're done. Absolute value of x plus 3. Next, Square root of 54 x to the second. We're gonna think about 54 with under a square root. We're gonna write it as 9 times 6. Then we'll split them. Square root of 9 is 3. Square root of 6 will keep. We cannot extract it. And that will give you absolute value of x. And we're done. Next. This one is the square root of 18x to the second over 4 multiplied by, that's not the fourth root, 4 times the square root of 3x to the second. So to make it more clear, I'm going to take the 4 out, but 4 is under a denominator. So it should stay under the denominator. That means it's not a 4, it's a 1/4. 4 has to be down. To make it clear that these two are the same square root, I wrote the 2. Now we could group them back together. Why? Because the nth root of the quotient is the quotient of the nth roots of the numerator and the denominator. So I'm applying this rule backwards. I do have this. I want to write it as one piece of square root on the left. Once you do that, notice that 18x to the second over 3x to the second as in a fraction inside, like this right here, could be simplified. Between 18 and 3, they both divide by 3. I got 6. X to the second and x to the second are, or they cancel. And that's it. 1/4 square root of x, or differently, we could write it as square root of 6 over 4. One more. Now here in this example, I'm boxing the given condition x is greater than or equal to 0. That means our domain is the non-negative numbers from 0 and right or above. 2 and 5 will be up front. We're going to move the 5 up front. We're going to look at these two together and put this on the side because we're dealing with the square root. So that is the square root of x to the second by putting them back into one piece instead of splitting them. We're using the same formula, and that's a 10. Now that will give you an absolute value of x, but since x is non-negative, we don't need the absolute value here. If you keep it, it's not wrong, but we don't need it. So we're going to take it off, and the reason is right here. Next example. I do have the powers here. Or the cubic roots, I want to put them back as one piece. Once you do that, or if you square them, that's another option, you get either way the cubic root of k to the second. That is if you apply this, and that is if you multiply them together with the being squared. Either way, it's the same thing. And we're done, because this one cannot be extracted. If I have a k cube inside, I could have it as 1k outside, but I don't have enough to be extracted. Okay. Here's another problem. Given that h is greater than or equal to 0, which means non-negative. So once we get the absolute value of h, we're not going to write absolute value of h. We're going to drop it because h is never negative. We're going to use the distributive property. We're going to multiply this by this, and multiply this by this with an addition in between. 7 times 3 is 21. 7 times 4 is 28. 21, 28. Multiply these two using a formula by grouping them back together. That's square root of h to the second. Multiply these two. I get one piece of square root. Multiply the inside part. H to the first, h to the third will give me h to the fourth. absolute value fetch, which is not needed. That's h to the second, and we're done. Next, given that a is non-negative, we're simplifying the following. Those are extra work if needed. How to add the fractions 1/2 plus 1/3. You need a common denominator, which is 6. And the answer is 5/6. Knowing also that the mth root of a is, as a power, is a to the power 1/m. And if you have a to the power n goes on top, and m is still 1/m. M is in the denominator. We're going to use those in this example. So here's the problem. And here's this as a power and this as a power. This is to the power 1/2 and this is to the power 1/3. When you multiply with the same pace, we're going to add the exponents, and it's done for us right there. So it's 5/6. Because they want us to write in radical form, we need to rewrite this as in radical form. The 6 is 1/6, which means it's a 6th root of a to the 5th. We're done with this problem. Let's move on. This video is going to be about 30 minutes. Already about 21, 22 minutes. Hopefully it's not going to go over 30 minutes, but I have a lot of examples, as you can see. Here we go. N multiplied by the following, cubic root and cubic root. Let's highlight the cubic root. Let's put them together because they're both the same. Group them this way in one piece. Simplify inside. 4 times 2 is 8. N times n to the second is n to the third. Now, dealing with the cubic root, I'm going to split them back again because this works nicely under the cubic root. And this also works under the cubic roots, which could be extracted. That will give me 2, and that will give me n. Using n is odd, we'll just take a by itself. In this case is n. Simplify n times 2 times n, 2n to the second, and we're done. Next example, 4x to the 4 over x to the second. That's a simple one. We could just cancel or simplify between x to the second and x to the fourth. We could split this too. And we're done. That's it. Okay, my last part, true or false. Do you think this is true or false? 2 rad x plus 6 rad x equals 8 rad x. I think those are like terms, so we could combine them. So, true. 16 cubic root of x minus 4 cubic root of x equals 12 cubic root of x. Yeah, they are alike. We could combine them. X times y to the power n. We could apply the nth to the x and y. Yes. Can I apply it when it's addition inside, like this? It looks right, but no. You could try it with numbers, it doesn't work. How about this example, 5 square root of x plus 2 cubic root of x? Can I combine them and make it 7? Because 5 plus 2 is 7. But I wrote cubic root of x here. Why? Because it's higher? We cannot do that. If this is cubic root and this is cubic root, we call them like terms. Yes, we could add them, but they're different. It's almost like you're saying 5x plus 2y. You cannot add them. So that's wrong. Only when it's like terms. Those are like terms, you could combine them. but those are not like terms, so we can't combine them. Two more examples. Square root of 16x over cubic root of 8 equals square root of 2x. It looks like they simplify between 16 and 8, right? You cannot do that. These are different. That's a second degree, that's a third degree. You cannot do that. That's like if you put them as one piece, but as a square root. But I do have a cubic root, so we cannot do that. Last example. Do you think x to the second to the third is x to the fifth or x to the sixth? Do you think this is true? That is true, and that should do it. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.